Welcome! In this video, we're going to learn some basics of the Python programming language by creating a simple encryption program. So let's show how it works. We're going to hit run and it says, would you like to encrypt or decrypt? So I'll say encrypt and I'll type a message. So for example, attack at dawn. And then it says enter a key, which has to be a number. It can be any number of digits. So I'll say 2345. And it's given us our code, our ciphertext. If we run the program again and we decrypt this time, and I put this message in and enter the same key, 2345, it will give us our message back. If we give the wrong key, then we will just get absolute gibberish back. And it will be unreadable. And I should say right off the bat here that we are not going to be able to create something that would stand up to modern security protocols here. We are just going to be making something very simple that is mainly focused on learning some of the aspects of Python. So please don't use this in any security sensitive application. So for this project, we're going to be using a free online Python environment called Trinket. If you just Google search the word Trinket, you'll get there quite easily. And this is a really fantastic environment for learning basic Python. Once you create more professional things, you'll want to move on to installing Python on your computer. But just as a simple web-based solution, this is very nice. So if you go up, or if you look up the top here, you can see that there's a sign up and login. You can simply sign in with your Google account is probably the easiest way. And then you will be able to just click on whatever your username is here and go to New Trinket and select Python at the top here. Before you get started writing any Python code, there are a couple of things to know. First of all, if you click on this button here and click on a larger font size, it may be easier for you to read. Another thing is that the free version on this website sort of has Python 2 and 3 all mixed in together, and we want to be writing in Python 3 at this stage. So if you go down here and copy and paste this line of code, and put that at the top of your program, then it will force the computer to process it in Python 3, which is what we want. Another thing to remember with Trinket is that it does not autosave, so you need to click on the save button as often as you can because you really don't want to lose any work. When you've finished a program, you can click on share, link, and copy this link if you would like to share your program with somebody else. For our encryption program, we are going to be using a simple substitution cipher. So we have the regular alphabet, which goes in order, A, B, C, D, E, F, G, etc. And we have the substitution alphabet, which is the same alphabet, but shuffled or mixed around. And what we do, let's say we wanted to take the plain text cab and turn it into ciphertext. We would take the first letter, C, and we would look on the table here and say, oh, that becomes a B, and then A, that becomes a T, etc. Now, we also need to know for both the alphabet and the substitution alphabet what the index of each letter is, which is a number attached to it, because from the computer's perspective, we need that extra step. So for example, what we would do is we would look up C, find out that its index is 2, and then go look for the letter in here whose index is 2 to transfer it. So that's an extra step. Substitution ciphers are these days not particularly secure. In about the year 850, I think, some mathematicians worked out that they're quite susceptible to what's called frequency analysis. So some letters in English are used, and in other languages are used much more than others. So E is the most commonly used letter in English. And if you have a big block of text, let's say 50 letters or more, you can usually, by calculating which letters appear the most, work out your own copy of the dictionary here, or the substitution alphabet, and just chip away at it. If you would like some practice in breaking substitution ciphers like that with frequency analysis, there's actually a very interesting activity on the code.org website. It's one of the hours of code. It's called Simple Encryption, and it's a lot of fun. So I'll leave the link to that in the description as well. So please feel free to go and see if you can break them. I will say, however, though, that a substitution cipher for a short message, let's say 5 or 10 characters, can be quite secure. All right, let's get started with our code. So the first thing I would like to do is to ask the user for their message and ask them for their numerical key. And our idea is we're going to take that key and always convert the same key or number into the same substitute alphabet. And we'll show you how you can do that. Okay, so if we make a variable called message, which will be the plain text or whatever the user has entered, it may actually be the ciphertext depending on whether they're encrypting or decrypting. So we'll set it to input, which brings a prompt up and asks the user something on the screen. So we'll say type your message, and I will leave a space here after the colon, just so that when the user enters it, there's more of a space here. And then the second thing we want to ask is we want to get the key. And we'll say enter your key. And put number in brackets in case they think that it is a word, because it will not work with a word for this case. Okay, maybe to test this out, we can just say print message key. So we'll print those two things. So if I type in hello and I type in 456, yes, okay, so we're storing those variables successfully. All right, so the next thing I want to do is I want to create my alphabet and my substitution alphabet. And we're going to use the key to generate our substitution alphabet. And I'll show you how that works in just a moment. So for alphabet, again, I'll just have that as a variable, and it will just be a string. So we can say we want A, B, C, D, E, F, G, H. We want all the letters of the alphabet. I might be a little bit lazy and copy that across, and I will leave it in the description for you to copy across as well if you wish, because you can see here I have included not just all of the lowercase letters, but also all the uppercase letters, all of the digits, and a space, full stop, comma, exclamation mark, and question mark, and you can add anything else onto the end of that that you like. So that's our alphabet, and then we want our substitution alphabet. I'm just going to call it sub alphabet, and for a start, let's just make a shuffled version of the alphabet. Then I will show you how to shuffle it the same way every time based on the key. So to shuffle a string is a little bit complicated because a string is what we call immutable, which means that it can't be changed. So we actually have to create a list from the string first before we can shuffle it. So I'm going to say list alphabet. Now if I print that, you'll see over here that, oh, actually, what I might do just for the moment is I'll put 3 quotation marks either side of this just to comment it out so it doesn't run. Okay, so there is our, it's basically a list with the same elements that the alphabet has. Now we can shuffle that if we import random. The random module has the ability to shuffle it, so we can just say random.shuffle sub alphabet, and there we go, it is shuffled. Every time we run it will be shuffled differently, so we'll have to fix that. And now we just need to turn it back into a string. Now this is one of the kind of weirder things here, but I will show you, and if it doesn't make full sense, don't stress too much. So sub alphabet equals two quotation marks, dot join sub alphabet. And basically what that means is join the sub-alphabet list together into a string using whatever's in these quotation marks as the character in between each entry. We don't want any characters in between each entry, so we've got nothing between these quotation marks. A little bit weird, but it works. So you can see now that we have our sub-alphabet is a nice string of letters here. That should be just the alphabet jumbled up, which will be good for our code. Okay, here's a bit that's very important. What we want is we want the user, the key that the user to enter in to result in the same shuffled list every time. A little bit like a seed in Minecraft creates the same random world each time, but it's not really random, it's procedurally generated. And that actually brings up an important point about Python and all computer programming languages. Random numbers aren't actually random, they're called pseudo-random numbers, and they're calculated by starting with a particular number. So if you start with the same number and then do a random combination, so start with the same seed number and then perform a random action, it will always be the same. Now, the way the computer makes this appear random is by using, for example, the system time off the clock as the random seed, which should always be different, right? Because time is moving forward. But we don't want that to happen. We want to seed our random generator with the key that the user has entered. So let's do that now. I'm going to bring these back into play. And we've got a number here from the user, except actually all input from the user is a string. So what I might just say is I'll set the key to be the integer, which means whole number, of the key. So that will get the key, which is a string, turn it into an integer, and save it back into the variable key. So now it should be an integer or a number, a whole number. Now what we want to do is we want to seed the random generator with that key. And now hopefully when I hit run, the message doesn't matter, but if I put the same key, 222, this is 6R3N, etc. Let's try that again. 222. So you can see our dictionary now is created, or our substitution alphabet is created the same way based on our key that we've entered here. If we enter a different key, so 3, or we'll do 223, you'll see that it's completely different. That way, now the user can just remember a short passcode or key and create their own, it's the same dictionary that the message was encoded in. So if I'm sending this to somebody, as long as we know the same number, we should be able to work it out, but nobody else, hopefully. Okay, so the next thing that we need to do is we need to go through that process where we go letter by letter along the message and substitute in the letter from the substitution alphabet. So how we might do that is we already have the message in a string here. So we already have the message, and we want to convert that into the encrypted message. Okay, so we'll say encrypted message equals nothing so far, and now what we want to do is we want to iterate or go over the message that the user enters. So let's say I hit run here, and let's say I type the message hello. We want to have a loop that will go through over each one of these letters and substitute it for the equivalent letter in the substitution alphabet dictionary. So let's do that. We need a loop, so we can say for, and I'm going to say char, which is short for character. So each character, so the H and then the E and then LLLO in message. Now I'm just going to show what this does by saying print char. So basically what's going to happen is the user's message here that they've entered, this loop will run once for each character or char in the message, and it will just print the letter. Now this is just a word that I made up. We could call this letter in both of those there, as long as they match up. Let's try running this. So if I say hello, you'll see it's looped over each one and printed it out. Now we don't want it to print it out like that. For each one, we actually want it to look up the correct letter in the sub-alphabet. Now remember, this is a two-step process. So let's say the first letter was a C. The first step is to find out the index of that letter, and the second step is to use that number to go and find out the equivalent letter in the substitution alphabet. Okay, so the first step is whatever the first character is in this message, we need to find out the index number of it. So the way we do that is I'll just make a little variable, I'll call it I for index, and to save the number in, and it's going to be alphabet.find char. So basically whatever the char is, it could be a C for example, then it will find the index in the alphabet string here. So if it was a C, it would be 2, for example, just like on the slide we just looked at. Now, the way that I use that number, let's say 2, that's stored in I, is I say the sub-alphabet. The way to get the second, well, it's really the third because it starts at 0, element in there is like this. And this will return whatever letter that is. It might be a P, for example. And we want to add that onto the encrypted message. Plus equals. Okay, hopefully that makes sense. So we find out the index number of the char in the regular alphabet, and then we go and look it up in the sub-alphabet and add it onto the encrypted message. Now, if I go back to the left, I'm unindenting because I don't want this to happen for every character. I want it to happen afterwards. If we print encrypted message, hopefully that will work. So I'll just try hello, and we'll just say 22 for the key, and H. Oops, that's because I put 2 there instead of I. Let's try that again. Hello. And there we go. Now, the final step of this is that we also need a way to decrypt. So we might go up to the top here and actually ask, I might make this a tiny bit smaller, and we might ask the user before we start whether, I'll just save this in action, a variable called action. I'll say, would you like to encrypt or decrypt? I will just paste this in. Okay. So it says select encrypt E or decrypt D. And what I might do is I might just put down there as well a dot lower. And what that will do is if they entered the E in capitals, it would just make it a lowercase, because in computer programming, a lowercase e and an uppercase E are 2 different ASCII numbers. And so we want to avoid that potential error. Now, if we go down here, I will say if action equals E, and all of this will go in the if statement, so I'll select it all and press tab. Okay. Now, I will copy all of this and say elif action equals D, so else if the action equals D, what is going to be different? Well, maybe we'll call this variable decrypted message, and it will be the I. We're going to actually look it up, instead of looking it up in the alphabet, we'll look it up in the sub-alphabet, and this will be decrypted message, and the letter we replace it with will be from the alphabet, so the other way around. And I might just add an else. I'll just print, please make sure you enter, E or D for, well, there we go, that'll be okay. Okay, let's test this out. So if we press run, we'll encrypt something and type your message. I'll just say hello, enter the key number 23, and we will then copy this, and we'll decrypt this time, this message 23, and we have our message back. Well, I hope you enjoyed following on along with this simple Python tutorial. Remember, the focus is really on us learning some Python rather than the decryption. It's good to understand a basic way of how decryption might have been done a long time ago in the past, but these days we need much more powerful algorithms that involve all sorts of prime numbers and things in order to keep hackers at bay, because if you throw a lot of computing power at something, it can break things very, very quickly. Make sure that you hit save, and I will see you in a future project.